What's up everyone, here we are with another video, hyperbolic functions, practice problems. We're gonna be doing question 5. Okay, so first off we got 5.1.1 says write down the coordinates of A. The coordinates of A is the point of intersection of the asymptotes. The asymptotes here are x is equal to 1 and y is equal to -2. So the coordinates of A would be 1 is to -2, like I wrote here. Okay, 5.1.2 determine the coordinates of the x and y intercepts of f. Guys, you know this one, very easy, but let's run through it. So x intercept, you let y equal to 0, and then 0 is equal to -9 x over -9 over x minus 1 minus 2. You take 2 to the other side, becomes +2. You multiply both sides by x minus 1. Okay, so here x minus 1 will cancel x minus 1, then this side x minus 1 will be multiplied by 2, which will then become x minus 1 times 2 is equal to -9. 2x minus 2 is equal to -9. 2x is equal to -9 plus 2. When you take 2 to the other side, then 2x is equal to -7. You divide it by 2, which gives you x is equal to -7 over 2. Therefore your x-intercept is -7 over 2 is to 0. Let's move on. 5.1.3 says write down an equation of the axis of symmetry of f that has a negative gradient. Now remember from the previous video that I said the axis of symmetry, right? The axis of symmetry are two straight lines that pass through the graph of f. Okay, the hyperbolic function. In fact, let me not say the graph of f, but the hyperbolic function, and they pass through the hyperbolic function and through the point of intersection of the hyperbolic function. Okay, through the point of intersection of the hyperbolic function. So here, to find the equation of that line, remember, since it passes through the points of intersection of the asymptotes of the hyperbolic function, which is a 1 is to -2, you're gonna sub that point in order to find the equation of the line. So here the only unknown that you need to find is c. So you sub the point a 1 is to -2. Okay, so 5.1.4 says hence or otherwise determine the coordinates of a point that lies on f in the 4th quadrant, which is the closest to point A. So here the closest point is the point of intersection of the axis of symmetry and the hyperbola. That's the only closest point to A, and that point is in the 4th quadrant because the axis of symmetry it passes through the hyperbola. It also passes through the point of intersection of the point of intersection of the asymptote. So the closest point here to A is the axis of symmetry and the hyperbola. Both of them are the closest to this point A. So in order to find the coordinates of that point that is closest to point A, we would have to equate the axis of symmetry, -x minus 1, and you equate it to the parabola, the equation of the parabola, which is -9 x minus 1 minus 2. Okay, so you take 2 to the other side, it becomes -x minus 1 plus 2, which is equal to -9 over x minus 1. Then you multiply both sides. You multiply both sides by x minus 1. Then x minus 1 here will be multiplied by -x plus 1. Okay, it's -x plus 1 because -1 plus 2 gives you a +1. So that's why we got this -x plus 1. Then you multiply this and that, which is equal to -9, like so. And then you you distribute, you simplify, you multiply out the brackets, gives you this, which is equal to -9. Then you simplify, and then x is equal to 4, or x is equal to -2. Now, since this point is in the fourth quadrant, x is gonna be positive here. So here, the point A, the point closest to A is in the fourth quadrant, and there in the fourth quadrant x is positive. So x cannot be equal to -2 for that point. So the only x value that it can be is 4. So you sub x is equal to 4 into any one of the equations. You sub x is equal to 4 into any one of the equations. The one for the axis of symmetry, you can sub it into the the line, the axis of symmetry, or the hyperbolic function equation. So I just decided to go with the easier one and sub it into the axis of symmetry. So y is equal to -4 minus 1, which is equal to -5. Therefore the point closest to A is 4 is to -5. Moving on to 5.1.5, which says the graph of f is reflected about the x-axis. To obtain the graph of g, write down the equation of g in the form y is equal to. So a reflection about the x-axis, you negate the y. So when you negate the y, like shown here, it will be -y is equal to -9 over x minus 1 minus 2. But we cannot have the subject of the formula to be negative. Okay, so we cannot have y being negative. So we divide both sides by -1, -1, which gives us y is equal to 9 over x minus 1. Pay attention to this one. Only this sign changes. Here the sign doesn't change. The sign changes here only. So it's -9 over x minus 1 plus 2.